Hello everyone. Today we'll talk about the solution to the problem rotating the box. This problem has two parts. One part is to deal with the rotation of the box, the other is to deal with the simulation of things falling down due to gravity. And it's that falling down which is more interesting. It's obvious that we can consider, let's say, column by column this operation of falling down. And the idea is quite simple. We have the bottom of the box, then maybe we have some obstacle and some other obstacle and so on. And for every stone above an obstacle or above the bottom of the box, we have to move all those stones to be stacked at the bottom. And there is an easy way of actually doing that, which is that we can keep in mind the next free space that a stone from above could occupy, and go through all the spaces one by one while remembering that slot. So we start with the bottommost position. Whenever we see a stone, we know that this stone will fall into that free position and our free position will move upwards by one spot. When we see an obstacle, the next free position is the position above it. And of course, if at the position that we're looking at there is already a stone, then we don't really care about that. We can imagine that this stone has just fallen into that position. It doesn't change anything, the position moves one up and that's it. So you can just go with essentially a normal pointer and a lagging pointer. That lagging pointer will be keeping the position where we write stuff back. This is a pretty common pattern in different types of problems and it is useful here. And the only thing else that we need to do is to rotate the box. So the implementation of this simulation, I've chosen to first implement the simulation so things are falling horizontally in this case, and then to rotate the box, but you can do it however you want. And now to simulate it, we remember height and width mostly for the later turning the box clockwise. We go for every row and we have to simulate every row backwards. So we start backwards. This is the next position where the stone can fall. And again, we go through every position in the row. If that position is a stone, then that stone falls at the position that we're pointing at. So we swapped the value of the position at that. So the position that we're pointing at and the current position that we're looking at with the main pointer. So essentially we either swap the stone with that empty space and it becomes an empty space, or if C is equal to target, then we essentially swap a stone with a stone. That doesn't change anything. And of course we have to move target backwards by one because that position is now occupied. And whenever we see an obstacle, then all the free positions under that obstacle are no longer eligible. We have to look at the position above that obstacle. So if at position C in the row there is an obstacle, the target becomes C minus 1, so the next free position. And now to return the box, we can do it, in my opinion, this is the most, let's say, easy to understand way, by a simple list comprehension. Because we have a two-dimensional array and we want to return a two-dimensional array. So we write first the outer array, then the inner array, and what do we need? Well, first of all, we have to swap the order of rows and columns. So we'll be having a row for every column that we had, and a column for every row, so that's fine. Of course, we have to index the original array by row and column, so this thing is also obvious. And now the only thing that we have to do is, instead of, because this would essentially perform a transposition, but we want a rotation, not a transposition, so we also have to reverse every row. And of course, it's up to your preference whether or not you want to first rotate, then simulate, or maybe do this reversal earlier, but this is essentially all equivalent and it's up to your preference.